Let's talk about how to use the computer's calculator to do a couple of problems involving continuous interest. Now remember, for continuous interest, our formula is A equals PE to the RT power. A is the future amount that we'll have. P is the principal that we're starting off with. E is going to be a key that we'll use on our calculator. R is the rate and T is the time in years. So now let's say that perhaps we have $500 that we're depositing in an account paying 10% continuous interest, and we want to know how much money will be in the account after 3 years. Notice the word continuous. That's what tells me that it is the PERT, or some people say shampoo formula. PERT instead of the big giant compound interest formula because we're using continuous interest. Now let's just substitute the things that we've been given into our formula first. We want to know how much money in the account after 3 years, so I don't know my final amount, my A. What I do know, the beginning amount, the principal, was $500. So in the place of P, let's put 500. E is going to be a key on our calculator. The rate, it was 10%, but we expressed that as a decimal. 0.1 is 10% as a decimal. Then finally, the time in years, 3 years, so 3 goes in the place of T. Now, as we try to compute this, let's first figure out what that exponent's going to be. Let's take 0.1 times 3 and multiply those things together. So 0.1 times 3, and let's press equals, it's 0.3 that is our exponent. Now, to be able to raise e to a power using the calculator on the computer, we don't have an e key as it stands. We've got to hit this INV key. That gets me to my second function, which was e to the x. Press that e to the x and it's evaluated for us. And then last thing to do is times the principal, 500. Press equals, and there is the amount that we'll have in the account after 3 years. Rounding for money, remember that we want to talk about pennies here, so this 9 rounds up to a 3 in the spot here. $674.93 when it's rounded properly. Now that problem was pretty straightforward, but maybe a little bit harder problem is this one. How much money must be deposited today if we're going to have a balance of $1,250 after 40 years with continuous interest at 8.5%? Now, same formula because we're using continuous interest again. So A is equal to PE to the RT. This time, though, we know the final amount. We know $1,250 is what we want in the account at the end of the time period. We do not know the principal this time. E is going to be a key on our calculator, and now changing 8.5% to a decimal is 0.085. It said that we had 40 years for our time. Again, let's evaluate what our exponent is going to be first. So let's say 0.085. Let's multiply that by 40, and you can see that our exponent needs to be 3.4. Now let's think about how these things on the right-hand side are being combined. We want to get P to be by itself. That's our ultimate goal. So these things are being multiplied together. To get rid of the multiplication, you need to divide. So if I'm going to separate P from these other things, I'll need to divide by e to the 3.4 power. Both sides of the equation must be divided. So what we'll type into our calculator, 1,250, I'm going to divide that by e to the 3.4. Now remember, to make that happen, I've got to type in 3.4, press I and V, then press e to the x. The calculator is currently showing me what e to the 3.4 would be. Let's press equals, and there is our final amount. Rounding for money again, the 6 makes this into a 2. So $41.72 is how much you would need to deposit today if you were going to have $1,250 at the end of the 40 years at 8.5% continuous interest. Take 1,250, that was the final amount, divide that by e raised to the 3.4. E raised to the 3.4, we type in 3.4, press I and V, e to the x, and then press equals, and there is our result.